So now let's look at what would happen if I were to have added sodium hydroxide to the buffer solution above. So again, I'm going to be starting with equal concentrations of acetic acid and acetate ion. And so what's really important with these buffer calculations is just that ratio between the weak acid and its conjugate base. And so this time when I add sodium hydroxide, the sodium hydroxide is going to be neutralized by the acetic acid. So the acetic acid concentration is going to decrease by 0.01 molar, and the acetate ion concentration would then be increased by 0.01 molar. And so after adding that sodium hydroxide, I should only have 0.09 molar acetic acid and 0.11 molar acetate ion. So now to figure out what the pH of that solution would be, I first need to solve for the hydronium ion concentration, which again is the Ka times the ratio of acetic acid to acetate ion. So the Ka is 1.8 times 10 to the minus 5, and that ratio now is going to be 0.09 divided by 0.11. Okay, to get the pH, I'm going to take the negative log of that answer, and we should end up getting a value of about 4.83. So a couple things to notice here. Yes, the pH did increase because I added base, that makes sense, but it didn't increase nearly as much as it would if there were no buffer solution present. So a pH, a solution with 0.01 molar sodium hydroxide would normally have a pH of 12. This pH only increased from 4.74 to 4.83. The other thing to notice is that the amount of change in pH by the addition of acid or base was equal in these two examples because I added equal concentrations of acid and base, and also because in my buffer solution I started with equal concentrations of acetic acid and acetate ions, meaning my buffer was able to handle the addition of acid and base equally. If that ratio were not 1 to begin with, I would not be able to handle the addition of acid and base equally. I'm going to be skipping the next page where you create buffers in the basic region of the pH scale, so please refer to the completed notes posted on Google Classroom. The calculations are very similar, except for, of course, you're going to be working with KBs and hydroxide ion concentrations instead of Kas and hydronium ion concentrations.